In this video, we'll be talking about the average acceleration and the instantaneous acceleration. And we'll also be given an example to differentiate between the average acceleration and the instantaneous acceleration. So what is the average acceleration? The average acceleration is denoted by a bar. And then it is defined as the change in velocity in a given interval of time. Or in other words, the final velocity minus initial velocity will give you the change in velocity, and then the final time minus initial time. So this is the formula for calculating the average acceleration. The final velocity minus initial velocity divided by the final time minus initial time. The average acceleration is a vector quantity. That means it does have both magnitude and direction. The unit of the acceleration, whether it is an average acceleration or the instantaneous acceleration, the unit is meter per second square. And one thing to make a note is the average acceleration is always measured between the two times. It is not measured at one time, it is measured in between the two times. And as I already mentioned, it is a vector quantity. Now let's talk about the instantaneous acceleration. The instantaneous acceleration is the acceleration at one particular time or one particular position. So it is at one particular time. And the average acceleration, as I mentioned before, it is measured between the two times, where the instantaneous acceleration is measured at one time. So how do you measure it? In order to measure it, we need to take the time derivative of the velocity, or the first derivative of the velocity with respect to the time. So that's how we measure it. This is the instantaneous acceleration, and it is measured at the rate of change of velocity with respect to the time. Or the second derivative of the position also gives you the instantaneous acceleration. All right. So, and again, it is a vector quantity, and the unit is meter per second square. Now let me give you an example to make a differences between the average velocity and the instantaneous average acceleration and the instantaneous acceleration. Let's say a car is moving and the velocity of the car is changing with respect to the time, and it is changing by this formula here. Vt is equal to 5 minus 10t. If that is the case, then what is the average acceleration between the two time intervals, between the time 2 seconds and the time this is 5 seconds, not the 50 seconds. I'll just make one minor correction correctly. This is the time is measured between the time 2 seconds and 5 seconds. All right. And okay. And then we also have to find out the instantaneous acceleration between those at the two times, time t equals to 2 seconds and 5 seconds. So let's start with the average acceleration now. So the velocity is given, and then we need to find out the final velocity, or the velocity at the time equals to 5 seconds. So just plug in the time equals to 5 into this equation. What I get is 5 minus 10 times 5, and it will be minus 45 meter per second. That's the velocity at 5 seconds. And then we also calculate the velocity at 2 seconds, which will be 5 minus 10 times 2. And it will be minus 15 meter per second. And by the definition, the average velocity, which is denoted by a bar, is the final velocity, which is the velocity at 5 seconds minus the initial velocity at 2 seconds divided by the time, the final time. The time at 5 seconds and the time. Okay, let me write down in a different way. Okay, so the way I'll just write down the final velocity minus initial velocity minus the final time minus initial time. The final velocity is the velocity at time t equals to 5 seconds, which is minus 45 minus, and the initial velocity is this time at the time equals to 2 seconds, which is minus 15. The final time, this time is 5 seconds and the initial time is 2 seconds. So what you get is minus 40 plus 15 divided by 3, which you get minus 30 divided by 3, and it is equal to minus 10, and the unit is meter per second square. So that is the average acceleration. Minus 10 meter per second square is the average acceleration. Now let's calculate the instantaneous acceleration. The instantaneous acceleration is defined by a equals to dvt over dt. That means the first derivative of the velocity. If we take the first derivative, it's a constant. The 5 is a constant term, so it will be 0. And if I take 10t, it will be negative 10. So the number is negative 10 meter per second square. So this is the instantaneous acceleration. And you see, it is not dependent on the time. So this one is not dependent on the time because it does not have any time term. So the instantaneous acceleration at the time, at all times, is exactly the same. At time equals to, let's say, 2 seconds, it is minus 10 meter per second square. And also at time equals to 5 seconds, it is still 10 meter per second square. Okay. Now let me give you another example of the differences between the average and the instantaneous acceleration. Now let's suppose, this is the example number 2 now. Now let's suppose the velocity is 5 minus 10 t square. And now we're going to find out the average acceleration and the instantaneous acceleration at time equals to 2 seconds and time equals to 5 seconds. And between these two time intervals, we're going to find out the average acceleration. So again, we need to find out the velocity at that time equals to 2 seconds, and this can be given by 10 times 2 squared. So it is 40 minus 5, you'll get minus 35 meter per second. And now velocity at 5 seconds, it will be 5 minus 10 times 5 square. So 250 minus 5, it will be negative 245 meter per second. So the average acceleration which is the final velocity minus initial velocity divided by final time. I will just write down at the bottom. Okay, so average acceleration is final velocity minus initial velocity divided by the final time minus initial time. What is the final velocity? The final velocity is the velocity at time equals to 5 seconds, which is minus 245 minus, and initial velocity is 35. The time is 5 seconds minus 2 seconds. So if we do the math, what we get, 245 minus 35 divided by 3, we'll get 70. So the answer is minus 70 meter per second squared. That's the average acceleration between time t equals to 5 seconds and time equals to 2 seconds. So this is the average acceleration. Now let's calculate the instantaneous acceleration. Okay, the instantaneous acceleration is defined as d, the first derivative of the velocity. Okay, and what is the velocity? The velocity is given by 5 minus 10t squared. That's how the velocity is given. 5 minus 10t squared. If I just take the derivative, it's a constant term. 5 is a constant term, so it will get 0. Minus 10 times 2t, you will get negative 20t. And now, let's put out the different times now. The time equals to 2 seconds. We'll get minus 20 times 2, and this will be minus 40 meter per second square. And now at time t equals to 5 seconds, it will minus 20 times 5, which will be minus 100 meter per second square. So you see now, the average acceleration between the time 5 seconds and the 2 seconds, we get minus 70 meter per second square. And this is the instantaneous acceleration. The instantaneous acceleration at the two times is different. One is at minus 40 and the other is minus 100. So these are the instantaneous acceleration. Okay. So this is how we calculate the average acceleration and the instantaneous acceleration. I hope this one helps you to understand the differences between the average acceleration and the instantaneous acceleration.